The directions say write a power series for the function f of x, which is 3x divided by x squared plus x minus 2, centered at c equals 0. Okay. So yesterday we did something a little bit similar to this. We looked at this, and the previous 4 questions were all closer to this than they were to this. So that's kind of the first issue we're running into here with this function f, is it doesn't quite look like any of that. But the denominator factors, which means we may be able to do something like this. We call this, by the way, partial fraction decomposition. So I'm going to do that over here on the side. So my common denominator, I multiply through by that and simplify. After simplifying, I have this equation. I'm going to try the shortcut. The shortcut works, by the way. So I get 2 for A and 1 for B. So we can express f of x not just as 3x divided by x squared plus x minus 2, or as 3x divided by x plus 2 times quantity of x minus 1, but also 2 over x plus 2 plus 1 divided by x minus 1. Okay. Now, these are awfully close to what we want. So think about what it is that we want. We want something like this. So this first one is already pretty much like that, except for this 2. I would like that 2 to be a 1. So how could I do that? Well, I bet if I factored a half out of everything, that would do it. No, that wouldn't do it. If I factored 2 out, that would do it, right? Distribute back 2x. Yup, we're good. Okay. So we can utilize now this series that you have memorized. Because we're centered at 0. Okay. I suppose I could do 2 divided by 2. That would be okay. All right. So this first one is this series. How about the second one? Second one, you know what? The second one is really close to that. What if I factor -1 out? I think I get that, right? -1 times 1 is -1. -1 times -x is positive. Yep, that would work. So what's that one going to be? That one's going to be this one. Right? Multiply. Oops. We're doing it this way. 1 plus -x. Yeah. Uh-huh. So that's -1 times 1 minus -x plus -x squared minus -x cubed. That's really neat. Check that out. Multiplying this by -1 is the same thing as multiplying this series by -1. How about that? So I forgot what the question is asking. I got so far into the weeds. It says write a power series. Okay. So what I have for f of x is 2 power series. I have, for the first one, 2 divided by x plus 2, 1 minus 1/2 x plus 1/4 x squared minus 1/8 x cubed, on and on forever and ever. And for 1 divided by x minus 1, I have -1 times the quantity of 1 plus x squared plus x cubed, on and on forever. So these are all negatives, right? Yep, those are all negatives. Okay. So f of x, look, there's some like terms. Neat. I get to use all my fun colors. All right. This and this. Those make 0. This and this. Those make -3/2 x, I believe. This one and this one, that's 4/4 x squared. That's a -3/4 x squared. And then this one and this one, that's a -9/8 x cubed. And it continues. Nifty little problem, if I do say so myself. So we're looking for the Maclaurin series for x arctangent of x. Now this is a little bit of a cheat because I don't expect you to memorize arctangent of x's Maclaurin series. So don't feel like you need to go out and track this one down. I just didn't want to use e to the x, sine of x, or cosine of x. I was getting kind of bored with those. So don't feel like you need to memorize arctangent of x, but arctangent of x has a Maclaurin series. Now this one has an interval of convergence that's different from the others, which is one of the reasons why I don't worry about it too much. It's not a factorial. I am forgetful. But with all that being said, this is still a problem worth considering. So think about what it is we're doing to arctangent of x. We're multiplying arctangent of x. So what I can think about doing literally is multiplying arctangent of x by x, which in the case of the Maclaurin series means I have all of these terms multiplied by x. So instead of 1 for the first term, we have x. And instead of x to the third, we have x to the fourth divided by 3. And instead of x to the fifth, we have x to the sixth divided by 5. And instead of x to the seventh, we have x to the eighth divided by 7. And to do the formula for the nth term, there's a couple of ways you could think about it. You could think about multiplying it by x. So you could say you've got something like this, negative 1 to the n, x to the 2n plus 1 times x divided by 2n plus 1. That works, right? If n equals 0, this is 1. Nope, that does not work. Okay, what else can we try? What if we do negative 1 to the n plus 1, x to the 2n plus 1 times x? Does that work? What do you think? Well, the sign would be wrong, wouldn't it? Because you get a negative, and the x would be wrong for that first term. You'd get a x squared, and the denominator would be wrong. No, the denominator would be right. 2 times 0 is 1. Okay. So that doesn't work. Does that work? What's going to work? That's your task.